So Martin, we are studying uh, third chapter, basically metals and non-metals, and here a new topic will be starting. The topic's name is basically how do metals and non-metals react? How do? So in class 9th, you have studied about the electronic configuration of element. Sarah, Martin, Hamna.
Yes, sir.
So there were shell, first shell that is known as K, then L, then M, then N. This is the basically electronic configuration of elements. So I'm going to write about noble gases. Noble gases, how many, not how many. Do you know what is noble gases? Arshia, Sarah, what is noble gas?
I think nitrogen is.
No, this is completely wrong. Martin, do you know what is noble gas? No. And Amna, so basically, I think you have seen periodic table, right? Have you ever seen periodic table?
Yeah.
So in the periodic table, the last column that is known as 18th group or noble gases, that is helium, neon, argon,
Krypton.
xenon, radon. These are all noble gases. And why they are called noble gases? Because they are stable. They have completely filled last shell. The last shell is completely filled, and since they are filled, the last shell is filled, they do not react with any other. They are stable elements, and they found pure in its nature, not like if you are going to see nitrogen always will be in the form of N2 molecule, not in the atomic form, but these noble gases are in atomic form because it is already stable. The stability for right now you can understand, like if any element which has complete octet, that means in the last shell it has 8 electron. If it has 8 electron, that is noble gas configuration, or you can call it is stable because it is completely filled octet. It has completely filled octet. Like if you are going to see helium, can anyone tell me what is the atomic number of helium? Sarah, what is the atomic number of helium? Arshia, Hamna,
7 minutes.
what you just said?
It is 2.
2. So you have seen that in class 9th, first shell is known as K, then L. This is first shell, this is second shell, then M, that is third shell, then N, that is fourth shell. Now you can see 2 in the first shell, it all 2 electrons will go, then 8, then 8, then 8. If it has less electron, then it will be like this. Now you can see that it has its atomic number is 2. That means it has 2 electrons. So the electronic configuration will be like. So you can see what I have written here in the K shell. That means first shell, there will be only 2 electrons. In the second shell, maximum electrons will be 8, and the third shell, maximum electrons will be 8. Now you can see, if we are going to write the electronic configuration of neon, can anyone tell me the atomic number of neon? That is 10. That is 10. So here it will be L also. So in the first cell, 2. Now whatever is the atomic number, that will be equal to the number of electron in neutral atom. If atom has no charge like this, is there any charge on helium? No charge. So its atomic number will be equal to the number of electron. And we right electron that is that comes in electronic configuration. Like neon has 10 atomic number, that means 10 electrons. Now in the first shell 2 electrons will go. How many electrons will how many electrons left? Only 8. So in the second shell maximum 8 electrons can go, so 8. So you can see this is also filled, this is also filled. So that's why they are stable and known as noble gas. Now argon, I'm going to talk about argon. Argon had atomic number 18. 18. Now you can see the first shell will have 2, then 8, then 8, 10 electron, and then how many electrons left? 8. So you can see all the shells are fully filled. So this is called noble gases. This is called noble gases. Now I'm going to take metals. We are going to do electronic configuration of metals. So metals. So I'm going to take first sodium, that is Na. Then I'm going to talk about magnesium. Can you do the electronic configuration of this?
Yes, sir.
And you know the atomic number, I think you know. Please write this and let me know when you are done with this. And then aluminum. I will help you in atomic number, but you should remember up to 20. This has atomic number 11, then 12, then 13. Please write it.
Sir, done.
Done, everyone? Martin, are you done with this?
Yeah, yes.
Okay. So are you done with this atomic number? Sorry, the configuration of this. You can see in the first shell, 2 electrons will go. In the second shell, 8, 1 electron is still left. So in the last shell, only 1 electron will go. Again, do for this magnesium and aluminum as well. Electronic configuration.
Sir, done.
Done. So 2, 8, 2, I think, and then
Yeah.
2, 8, 3. Yes or no?
Yes, sir.
Now do for potassium K, which has atomic number 19, and calcium Ca, which has atomic number 20.
Sir, done.
So, Arshia, are you done with this? Hamna?
Yes, sir.
Okay. So it will be 2, 8. 10 electrons, 9 electrons left, then 8, 1. Now 2, 8, 8, 2. Yes or no? This is the electronic configuration of potassium and calcium.
Yes,
now
sir.
you can see now you can see that there should be at this place there must be 8 electrons to be stable, but you can see only 1 electron is there. Now there is 2, 3, 1, 2. That means they are not stable. That's why they are reactive. And whenever you are going to found it in nature, it will be in compound form or molecule form. Mostly it will be in compound form. To get its stability, it reacts with other substances to fulfill its octet. Are you getting my point? In order to stabilize itself or fulfill its octet, it react with other substances like sodium react with oxygen to form sodium oxide, and in that case it becomes stable. Everyone getting my point? Sarah?
Yes, sir.
Yes, sir.
Now see the difference. Here is most important point is that, can you tell me the valency of sodium, magnesium, aluminum, potassium, and calcium? Valency. You have studied about this in class 9th. Do you know what is valence electron? Do you know valence electron? Valence electron, that means electron in last shell. Electron in last shell. So what is the valence electron of sodium?
1.
1. What is valence electron? Valence electron is the number of electrons present in last shell. This is first cell, this is second cell, this is third cell. And for sodium, this third cell is the last cell. So
Yeah.
valence electron will be 1. So whenever valence electron is equal to or lesser than 4, that will be equal to valency. What I want to say is that whenever valence electron will be equal to 1, 2, 3, 4, whenever valence electron will be equal to 1, 2, 3, 4, that will be equal to valency. But whenever valence electron greater than 4, that means valency will be equal to 8 minus whatever is the valence electron. Valence electron, you will get it easily in the next step. That means if you have valence electron 5, that means valency of that will be equal to 8 minus 5, that will be equal to 3.
Yeah.
Sarah, Martin, Arshia?
Yes, sir.
Yes, sir.
Yeah.
Very good. So what is the valency of this sodium? It will be 1. What is the valency of magnesium? It will be 2. What is the valency of aluminum? It will be 3. What is the valency of potassium? It will be 1. And what is the valency of calcium? It will be 2. Is that clear?
Yes, sir.
So see, whenever reactions takes place, whenever a compound is formed by covalent, either by covalent or ionic bond, we need to focus on the last shell electron. That means we need to focus on the valence electron, not inner shell electron. What is inner shell electron? You can see this is first shell, this is second shell, this is third shell. So this first and second is inner shell electron. So this inner shell electrons do not participate in reaction or do not participate in any formation of compound, but the valence electron participate in the formation of compound. So first of all, you are going to write the valency, which is very important, and we will use this. Let me know when you are done with this.
Sir, done.
Completed.
Very good.
That answer.
Martin and Amna. Okay.
That answer.
Now see, very good. Thank you. Now see, this is we are going to talk about non-metal. So you are going to write the configuration of non-metals like nitrogen, and I think everyone knows the atomic number of nitrogen,
Yes.
oxygen, fluorine, phosphorus. Martin, have you studied this chapter before, or is it first time?
First time.
First time. Very good. So, if you have any doubt, if anyone have any doubt about atomic number, please ask me. Abdullah, why are you late?
Sir, I was in the washroom.
Okay. Please do the electronic configuration.
Sir, done.
Everyone done with this?
No, sir, 1 minute.
Okay, take your time.
Completed, sir.
So nitrogen has atomic number 7. So you know that in the first shell there will be only 2 electrons going, and how many electrons left? 5. In the
5.
second cell, 8 maximum can go, but we have only 5 left, so this will be 5. It has atomic number 8, so 2 comma 6.
6.
Now fluorine has atomic number 9, 2 comma 7. Now phosphorus has atomic number 15, so 2 and then 8 and then 5.
5.
Sulfur has atomic number 16, so 2, 8 and then 6. It has atomic number 17, so 2, 8, 10, 7 left, so it will be that. Now you are going to calculate the valency, which is very important.
Sir, done.
Very good. Very good. What is the valency, Martin? Can you tell me the valency of nitrogen?
3.
3. Very good. Sarah, can you tell me the valency of oxygen?
2.
What is the valency of fluorine? 1. Again, it is 3, and then 2, then 1. Periodic table is very easy. It follows a pattern. If you are going to see it carefully, you can easily remember all the things from the periodic table. Everyone done with this? Arshia,
Yes.
Yes, sir.
do you have any doubt in valency?
No,
Amna
sir.
and Abdullah?
No, sir.
Very good. So now we are going to see how do metals and non-metals react. So I'm going to change the slide, and you can see there is sodium. There is sodium, which is denoted by Na. And sodium has electronic configuration 2, 8, 1. And in order to get a stable, okay, in order to stabilize itself, sodium, in order to stabilize itself, what can sodium do? Either it can gain 7 electrons, or either it can lose 1 electrons. If it will gain 7 electrons, it will have configuration 2, 8, 8, which is fully filled octet, which is fully filled outermost shell. And it can or either it can lose 1 electron, and it will have a configuration 2, 8, which will achieve noble gas configuration. So what will be easy for sodium? To gain 7 electrons, or to lose 1 electrons? What will be easy? What do you think?
Lose 1 electron.
Arshia, Abdullah, Hamna, and Martin. To gain 7 electrons or lose 1 electrons? What will be easy? To lose 1 electron. So what will sodium do? It will lose 1 electron. And whenever an element lose 1 electron, there will be plus 1. And whenever an element lose 2 electrons, it will be plus 2. In the same way, if an element gains 1 electron, there will be 1 negative charge. And if an element gain 5 electrons, that means there will be minus 5 charge. So it loses 1 electron, and you can see it has configuration. Now it loses 1 electron, that means only 10 electrons left with Na plus. So it will have a configuration 2, 8, and you can see that this will have fully filled octet. Yes or no? Octet, that means 8 electrons in the outermost shell. Sarah, Martin, Arshia. Very good. So we call it sodium cation. You know that there are 2 types of ion. You already know that ion are of 2 types: cation, that means positive charge, and anions, that means negative charge. Now see, chlorine. Chlorine, can anyone tell me the configuration? 2, 8, 7. So what will be easy for chlorine? To gain 1 electron or to lose 7 electrons? What will be easy? To gain 1 electron. So what will chlorine do? Sodium loses 1 electrons, and what will chlorine do? Chlorine gains 1 electron from here, and it will be Cl minus, and it will have a configuration 2, 8, 8. And we can write chlorine anion. Chlorine anion. Now you can see, I'm going to write the reaction. I am going to write the reaction. This has 1 electron in the outermost shell, and chlorine has 7 electrons in the outermost shell. And what happens? Sodium just loses 1 electron, or you can see sodium just gives 1 electron to chlorine, or you can either say sodium loses 1 electron and chlorine gains 1 electron, and it will be like Na plus and chlorine will be like, so you already know that negative and positive charge attract each other. There will be electrostatic force of attraction, and here how it reacts. Sodium loses 1 electron, it will have positive charge. Chlorine gains 1 electron, it will have negative charge, and there will be force of attraction between positive and negative charge, that is known as electrostatic force of attraction. Negative charge attract each other, so there will be bond formation between these two, and this is known as basically ionic compound. Ionic compound. Whenever one element lose electron and another element gains electron, there will be positive and negative charge, and there will be force of attraction, electrostatic force of attraction. Please write.
Sir, can you
Yes.
say? Can you explain the last one again?
What I need to explain?
The last one.
The last one, ionic compound.
Yes, sir.
What is ionic compound? So basically, ionic compound, you can see metal or an element which loses electron, and basically complete transfer of electron takes place. We can say complete transfer of electron takes place. Now you can see sodium gives electron to chlorine. When sodium loses electron, there will be positive charge, and when chlorine gains electron, there will be negative charge. And you know that opposite charges attract each other. Sarah?
Yes, sir.
So what will happen? There will be force of attraction between these two, and they bonded together with this electrostatic force of attraction, that is known as ionic compound. So we can define it like complete transfer of electron takes place. Okay, I will define it in a more specific way. Wait a minute. Martin, are you?
Yeah.
Yeah, got it. Everyone, please write.
Sir, done.
Everyone done with this? Arshia, Abdullah,
Yes, sir.
Hamna, Martin.
Yeah.
Yes, sir.
Very good. So write a definition. Compounds made up of ions that form charged particles, that forms charged particles. When an atom gains or loses electrons are called ionic compounds. Please write.
Done, sir.
So there will be some question like have written Na in the same. First write it, then I will explain how you are going to do the question. Everyone done with this?
Yes, sir.
Arshia, Martin, Abdullah, Hamna.
So,
So you are going to make or prepare MgCl2. Wait a minute, not MgCl2, KCl, in the same way that NaCl we just did. Can you do this? First, you have to write the first step. That is this, then chlorine and this step. Are you getting my point? Sarah,
yes,
Abdullah?
sir.
Okay. So you are going to prepare KCl.
Sir,
Yes.
is it like KCl gives us K plus plus Cl minus?
Yes, it is like that. You can see K will have electronic configuration 2, 8, 8, 1. And what happens? It loses one electron. That's why there will be 1 plus positive charge, and 1 electron it loses. Now it will get noble gas configuration. Now chlorine will be here. That will gain 1 electron. In neutral state, it will have configuration 2, 8, 7. But after gaining electron, it will be negative. That means whatever its atomic number, there will be 1 electron added, because negative charges shows that it gains electron, whatever is the negative charge. If only single negative, that means 1 electron it gains. If minus 2, that means 2 electron it gains. So it will have configuration 2, 8, 8. Now what happens here? You can see potassium, and here you can see chlorine. This is the electron representing in the outermost shell. So what happens here? It will give 1 electron here, and what is it? K plus, and then we can write Cl, 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 and here it will be negative. So there will be force of attraction between these two negative and positive charge that will help it together. Have you done it in the same way?
No, sir.
Oh,
A little different.
Just correct it and let me know. Martin and Abdullah, Arshia and Hamna. Please do this. And if you have still any doubt, please ask me. I'm here.
Sir, in that K and then K plus C, can you explain that?
What you just said, K plus
K plus E minus.
K plus E minus. E that represents one electron. If there is two electron, it will be written like 2. This is the representation of electron.
Okay. So
We're done.
Done, everyone?
Yes, sir.
yes.
Okay. Now there is another question on the same base. MgCl2. You are going to make MgCl2. Please do this. Everyone done with this?
No, sir. So can you explain this monality?
Yes, why not? Just wait a minute. So see, you know potassium, magnesium has atomic number 2, 8, 2, and what it will do to achieve electron noble gas configuration, what it will do, lose 2 electron or gains 6 electron,
Looks.
lose 2 electron. So when it will lose 2 electrons, so it will have +2 charge,
Yes, sir.
and 2 electron loses. Now you can see there is 2 chlorine. So what happens here, one chlorine has an configuration 2, 8, 7, and one chlorine, in order to achieve electronic configuration, one chlorine will gain only 1 electron, yes or no?
Yes, sir.
Yes, sir.
So there will be 2 chlorine which will gain electron Cl minus, and it will become 2, 8, 8, yes or no?
Yes, sir.
Yes.
So if you are going to write this Mg, there will be 2 electrons like this and this, and there will be 2 chlorine. There will be 2 chlorine like this, and 1 electron will go to this chlorine and 1 electron will go to this chlorine, and there will be Mg plus 2 charge. And now you can either write Cl minus or Cl minus, or in order to write you can write 2, 4, 6 and 8. In order to if you want to do it like this, you can write this also, or you can write like this, Mg plus 2 and 2 Cl minus, because one Cl has one negative charge and there is 2 Cl. So like this. Are you getting my point?
Yes, sir.
Yes, sir.
Please write it.
Sit down.
Done, everyone?
Yes, sir.
Yes, sir.
Very good. Now see, if you have understood this, which is very easy, so can you do this question in the same way? CaCl2. Can you name this compound?
Calcium chloride.
Very good. Please do this. Are you done with this?
No, sir.
Okay.
Sir, is it like Ca plus 2 and
Hmm.
2Cl minus?
Yes, very good. Martin,
We
are you done
do in
with
the
this?
same way, right?
Yes, yes.
Yes.
So you can see calcium, which has electronic configuration 2, 8, 8, 2. And for calcium, it's easy to lose 2 electron in order to get noble gas electronic configuration 2, 8, 8, and it will be like this. Again, there is chlorine, you know that. And what will chlorine do? Chlorine will have a configuration 2, 8, 7. In order to gain noble gas electronic configuration, it will be like Cl minus 2, 8, 8. Now you can see calcium has 2 electrons, and there should be 2 chlorine involved because one chlorine can get only 1 electron. So it will be like this. This will be like this. And what happens here? Mg plus 2. And we can also write like this: chlorine, 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 and 2. Or we can either write, yes, this is good. Write
Sir?
it write in this way, not in this way. Okay.
Sir, why did you wrote Mg?
Oh, sorry. This should be Ca plus 2. Ca plus 2. And not write it in this way, write it in this way. I'm going to recorrect it. Okay.
Done.
Are you done with this?
Yes, sir.
Amna and Abdullah. Okay, I'm going to give you a question. Write the electron dot structure. Sodium, oxygen, and magnesium. Please let me know if you are unable to solve this question.
So can you show like first one?
Yes, why not? It's very easy. You just need to. You just need to show only the outermost shell electron. Like sodium, if you are going for sodium, you know the configuration 2,8,1. So if you are going to show electron dot structure, so sodium and 1, whatever is its outermost shell electron, you just need to write
Okay.
that number.
So done.
Okay. So what is for oxygen? There will be 6 electrons. And
Yeah.
what is for magnesium? There is 2
Two.
electrons. So this is how we are going to write electron dot structure. Whatever is its valence electron, you just need to show that. Okay, everyone.
Yes, sir.
Martin, Arshia, do you have any doubt? In Abdullah, Hamna, please let me know if you need any explanation in this lecture.
Sir, could you explain the E and K part?
Yeah, ask it again. E and A.
E and K part.
E and K, what you are saying? I'm not getting you. Martin,
Yes, sir.
what you just said?
Could you explain that E and K part? Like, so,
Which E and K part you are which part you are saying? KCl,
yeah, that.
this. Are you talking about this KCl?
Yes, yes, sir.
So you can see we need to make prepare KCl. Potassium has atomic number 19, 2,8,8,1. So in order to achieve in order to achieve noble gas configuration, what it should do? Either make it 8 or make it 0. If you are going to lose 1 electron, this will be noble gas configuration, or it can gain 7 electron. What will be easy? It will be easy to lose 1 electron.
Yeah,
So it will lose electron and it will achieve noble gas configuration, 1 electron lost. Now chlorine is there. It has 7 electron in its outermost shell. So in order to get a stable or achieve noble gas configuration, it will gain this electron. So now it just gain electron. Now I just represented K1 electron, K and 1. This electron will go to chlorine, and since it loses, it will have positive charge. Since it gains, it will have negative charge, which will make a bond between